So we're more than delighted once again to have David from Aave back to give a talk today on kind of building on Aave. You'll remember David from a few weeks ago in our kind of product stack event, which was a fantastic explainer into where kind of Aave fits in the grander kind of DeFi ecosystem and why lending is so important. And today we're going to kind of add to that talk and give you a few more tools. In the second half of this event, we hope to have Patrick from Chainlink, which is an Oracle platform, which actually dovetails very nicely into everything else we've done in this series. He'll be giving a talk on how you would integrate kind of Chainlink into your designs. But David, thank you so much for being here with us. And yeah, over to you to kind of tell us more. Thank you very much.
Awesome. Thanks for having me again, Anthony. So yeah, as Anthony said, I'll go over the slightly more technical than last time. Some of the content will be the same, but I'll dive more deeply into the code. I think you should be able to see my screen now.
Yeah.
Right. Cool. All right, so we'll dive straight in. I'll try and bring up the question. Let's see. Well, when you have questions or comments, feel free to post them. Maybe someone can let me know.
Yeah.
Yeah, so we can do it dynamically like that. All right. So for those that don't know, I'll just quickly go over the basics of Aave, and then we'll dive into some of the code and how you'd implement Aave. So Aave is a liquidity protocol. On one side, there's depositors, and they deposit assets like ETH or DAI or whatever else into the protocol, and they earn interest in return. And on the other side, we have borrowers, and borrowers can borrow funds as they need to based on a stable variable interest rate, and they can pay back those loans whenever they need. The important thing here is that both borrowers and depositors interact with a smart contract protocol rather than interacting with each other. So since launch in early 2020, it's been a huge amount of growth. TVL currently sitting around, I think 5.8 billion. That shows that was taken probably a few weeks ago, or 1 or 2 weeks ago, and the market size is more than $6 billion. So there's a lot of traction, a lot of funds, a lot of trust in the protocol. And then also recently we announced our first L2 or sidechain market, which is on Polygon. So now you can also, deposit and earn interest and borrow funds on Polygon, which used to be called Matic. So there's 3 markets at the moment. So the main protocol features, these are all the same for each of the markets except the governance part. So you can earn, that's by depositing tokens, and you'll get one-to-one A tokens in return. You can borrow, and there's the stable and variable interest rate, credit delegation, flash loans, and governance. And I'll go through each part in more detail in the following slides. All right, so since it's a bit more technical crowd, I'd imagine that I can jump straight to the DeFi explanation instead of stepping through each explanation. But essentially, we tokenize your deposit. So you send in 100 DAI, you receive 100 A DAI in return. And the account holding those A tokens accrue interest based on certain parameters and demand. So schematically, it's the depositor, they deposit some sort of asset into the protocol and they receive interest. And the interest is based on protocol parameters like utilization rates and things like that. I'm just having a look at the questions that are posted. So we currently use the Chainlink for all the oracles. So that's how we determine whether borrows and positions are in a safe zone or not. Yeah, and I see Patrick already mentioned that, which is cool. And so from a technical standpoint, for developers to deposit or earn interest, it's quite easy. Essentially, the most important line is the bottom part here. So you call the deposit function on the lending pool, and you just pass in the assets, which is in this case DAI. So it's the address of DAI, the amounts, and of course that's in the standard units of that asset on behalf of, and that's I'll go into that a bit later, but that's related to credit delegation. If you're just doing a standard deposit, you'd always just use the message sender and a referral code, which is at the moment isn't properly live, but that will come into play a bit later on during as governance starts to propose some things around referrals and things like that. And like all Solidity standard ERC20 tokens, initially you have to approve the transfer of those assets. So you call approve and you allow the Aave lending pool contract to essentially withdraw your tokens from your address for a certain amount, and then you deposit those amounts. You call deposit function. And now lending pool will grab those tokens from your address, deposit it in, and essentially what we do in the contracts, you can see, and also in our documentation, is we take what's called a liquidity index and a time, like a snapshot of when you deposited in the protocol, and then that's how we determine how much interest you earn over time. So that can be quite complex. There's a lot of maths involved and other things. If you're interested in that, yeah, see the developer docs. Also, we have the risk docs. So docs.aave.com/risk, and that dives into the maths and some of the other things around that. So Don had
questions in the chat, David. Would you like me to read them out?
No, I can see them here.
Sure.
All right. So Vin, when is your L2 marketplace available via public? So the L2 market, or Polygon, which is a side chain. So Polygon is available now. And if you're meaning public API, as in the data API, most of the data is available through the Aave API or the subgraph. But you can use it now, and there's, you know, I think there's like $300 million worth of TVL in the Polygon market at the moment, and there's also a liquidity mining thing happening on Polygon where people are earning Matic tokens. So it's pretty cool and it's super cheap and fast. I use it and play around with it. So I'd recommend definitely trying it out because it's super cheap to use Aave on Polygon as opposed to mainnet. And then Don had a question: how important are decimals when building smart contracts? Yeah, so decimals are important in that, well, firstly in Solidity it doesn't support decimals, so you always have to, you know, multiply by some exponent like this, and 18 is the general number. Like, it helps with accuracy. So instead of saying 100 units, you just say 100 with 18 zeros at the end, and that's sort of another way of calculating accurately when Solidity doesn't support decimals in the language. So yeah, that's quite important. And I think maybe what you're referring to is that most assets use 18, let's say exponent 18, but other mostly stable coins like USDC is 8 decimal places, or exponent 8, and then you have wrap BTC, which is 6, and things like that. So that can trip you up sometimes. It's happened to me a few times. So yeah, be aware of that. So once you've deposited some assets into the protocol, you can easily withdraw them whenever you want. So similarly, you just call withdraw on the lending pool, and you say, you know, that type of asset, the amount, and the address that you want to withdraw it to. The amount here, you can see UN-1. That's an old way of doing it in Solidity. That's essentially like withdraw everything that I can withdraw. I think the new way in Solidity is type max something. So you can do the max amount that you want to withdraw everything, or you can say specifically how much you want to withdraw. And then, as I said, it's 1-to-1. So it will basically burn the amount of A tokens that you have, and then in return you'll get the underlying tokens, ERC20 tokens. So similar with borrowing, once you've deposited into the protocol, you receive those A tokens, and those A tokens can be used as collateral, and that means you have a collateral position. So that's where Chainlink also comes into play, where it calculates the value of your collateral position. Then you have a credit line essentially, so you can now borrow either at a stable interest or variable interest rate. So how this looks schematically, as I mentioned, you deposit, then you have a collateral position in the protocol, and therefore you can take loans and pay back those loans whenever you want. So pretty simple and straightforward. in that sense. So to make a borrow, as I mentioned, you already have to have collateral in the system. Once you have collateral in the system, then it's pretty simple. Just like before on the lending pool, we'll call the method borrow, and you pass in the asset you want to borrow, the amount, remembering the decimal places, the interest rate mode. So whether you want to take a stable interest rate debt or a variable interest rate debt, you just pass in the correct number. The referral code, as I mentioned before, doesn't really apply at the moment, but in the future, it may apply depending on governance. And on behalf of, which also, as I mentioned before, that's more related to credit delegation. But for now, in this section, you can just pass in message sender, and that will borrow and send those borrowed assets to the person that called them. Yeah, and I'll go through Smithy asked about flash loans. I'll go through some flash loan code a bit later on as well. Right, so once you've made a borrow, you can also easily switch your borrows and just on the lending pool, just call swap borrow rate mode, plus an asset and interest rate mode. The thing to be wary or aware of with this, especially for your users or for yourself, is that if you have a really good stable interest rate and then you swap to a variable interest rate, if you swap back to stable interest rate, you're going to get the current stable interest rate. You're not going to get your previous stable interest rate. So yeah, just be aware of that, because sometimes you may think you're chasing a better interest rate, but you might end up with a worse one. And these days with liquidity mining and farming and all that sort of stuff, the stable interest rates can essentially climb pretty high over time. And if you want to repay back your loan, you can repay at any time. Very similar like the other methods. It's an ERC20 token that you're repaying with, so you approve the lending pool to pull that amount, and then on the lending pool contract you just call the repay method and you pass in the relevant parameters. The only thing with this is that so you can call repay anytime if your collateral position, the health of the position, we call it health factor, goes below 1.0, then you can be liquidated, and there's a network of independent liquidators that will call the liquidation function and essentially repay back the loan for you, but then they will receive your part of your collateral at a discount. So you want to ensure that you're the one repaying, so you're paying the proper amount. So next is credit delegation. The important part here is that previously when I talked about depositing and borrowing, is that the depositor and the borrower is the same person, but with credit delegation, the depositor can be different from the borrower. So what that means is that someone, let's say myself, I deposit into the Aave protocol, and maybe I have no use case to borrow assets, I just want to earn interest, but there's an existing credit line there if I want to use it. Instead of using it myself, I can give it to someone else to use, and maybe that other person doesn't have collateral in the system, but they can draw credit up to a certain amounts that I've set for them. So that's quite powerful, because that allows essentially uncollateralized borrowing from the perspective of the borrower, because they don't need to deposit anything. But ultimately, me as a depositor, I'm taking on all the risk. But you can do some pretty cool things with this, some use cases, which I'll go through a bit later if we have time. But the to conduct a credit delegation in V2, what you first need to do is get you interact directly with the debt token. So in V2, Aave V2, we have stable debt tokens and variable debt tokens. So these are separate. So then on here, say this line for a stable debt and this line for variable debt, you'd pass in the address of the stable debt token, and then you just say approve delegation, similar to the ERC20 approve function. Say approve delegation for this borrower and the amount that they're allowed to borrow. And then once that happens, that user, the borrower, is able to call the borrow function like in the previous slides, and they'll be able to borrow up to the amount that you've set. So that's pretty cool and pretty easy to do. Yeah, so as I mentioned, so the borrower, just exactly like before, just on the lending pool calls borrow. So if you want to do this through your own contract, because maybe you want to charge interest on top of whatever the protocol interest is, you can also do that, but it requires a bit of in between and making sure you track how much credit they're allowed to borrow and things like that. But it is possible, and other people have done it. But it does open up a huge design space. For example, business to business lending. That's a big use case for something like this. All right, and anyone can repay back the debt of the borrower, but of course, generally it's the borrower that would repay it. But maybe if you create your own protocol around this, you could probably incentivize other people to help repay someone else's borrow. And I don't know, you can create some incentive mechanism out of that. But it's super simple. I mean, the standard method is that you're repaying, but then you're saying you're repaying on behalf of this delegator. And if I go back a slide, this is where you'd use on behalf of. That's where it becomes important as well. So here, the person that has been, they say, I'm borrowing on behalf of this person that gave me a credit line. All right. Yep. So yeah, as Anthony said, I'm from this. We're talking about Aave here. If that wasn't obvious. So quickly go through flash loans. So I think everyone here is mostly technical. So I won't go through that explanation. But essentially, yeah, it's an uncollateralized loan that you can take as long as you pay it back before the end of the transaction. And you can do any arbitrary actions in between the flash loan and repaying. So in a schematic form, flash loans are always conducted from a smart contract because you need to code them. And what would happen is your smart contract would call the flash loan function in the Aave protocol. The protocol would do some sanity checks, and then it would send those funds, whatever funds you requested. Let's say in this case it's DAI, and let's say it's a million DAI that your contract requested. It would send that million DAI to your smart contract, and your smart contract can do whatever it needs to do. In this case, it's paying back a CDP, it's liquidating that underlying ETH, and then it's swapping that ETH for DAI on a decentralized exchange like Uniswap. And then it's using that DAI that it just swapped to pay back the $1 million flash loan debt plus the small 0.09% fee. And then maybe there's a profit that's left over, then that can be sent, or you can code that to go wherever it needs to go. The important thing here is that everything below the purple line can get reverted like it never happened if you don't repay back the flash loan at the end of the transaction. So that means that the EVM will still step through each of your let's say state changing actions and methods. So it would incur some sort of gas costs, right? And then it would revert, but you still pay that gas cost. So just be wary of that. Sometimes it doesn't matter, sometimes it does matter depending on what you're trying to do. So Judy, flash loans are pretty cool. I wouldn't say they're discovered, they're probably like created. I think that they were created a few years ago, or maybe a few years ago by some other protocol, but they weren't really well known. I think DYDX had them for a while, but they weren't known as flash loans. And then Aave, I guess, brought it to more the public consciousness. Flash loans are a bit of a commodity. A lot of different protocols have them, but I'd say that our flash loans are quite well used. One of the reasons why is because it can be on any of the supported assets, and also there's quite a lot of liquidity. So you could flash loan, $10 million if you really wanted to, and of course, you'd have to pay it back and pay the fee. So this is an example of what a flash loan looks like on Etherscan. There's a bunch of transactions that happen quite quickly, and it's all in one transaction. And Etherscan has a cool thing where they'll say it's a flash loan of this amount from Aave. And similarly with a arbitrage, generally flash loans will be used for buying low somewhere and selling higher somewhere else. And in that case, you're not capital constrained. So maybe the arbitrage only works if you do a buy of $10 million. Now you don't need $10 million sitting there, because now you can just flash loan $10 million and then make some profit. So for Judy's question, I'm not sure on the daily volume of flash loans. You could probably use various dashboards out there to find that, Nansen or There's a few other dashboard types. I'm not sure exactly what the daily is, but I think Alex from our team, she sends out a weekly report generally on Twitter or via email that probably has that sort of data each week. How does gas work for flash loan? Judy has another question. How does gas work for flash loan since there are loads of transactions? Yes, as I mentioned before, the EVM still steps through all your state changing methods and state change and things that you do in your contract. So it still incurs some sort of gas costs because the EVM still churning through your or stepping through your code. So yeah, you'll still incur that gas cost, but of course it won't be as much as a completed transaction. So just be aware of that. In Aave Protocol v2, we have batch flash loans. So what that basically means is you can flash loan multiple assets at different amounts, also at different debts, which I'll go through in a second. And it's all in one transaction. So that's pretty cool if you're trying to, let's say you've borrowed 15 different assets on Aave and you just want to close all of those positions down. Like you want to repay all of them and close it all down because you want to exit because the market's tanking. So now you can do that just with one transaction, of course, pending gas limits and whatnot. But that was a thing that wasn't possible before, but now it is possible. So Peter has a question. So collateral swap with MakerVault, when was the real outcome of those transactions? So with the collateral swap, so that's actually something I built probably about a year ago. So the purpose of collateral swap, or my collateral swap with the MakerVault, is not for profit. It's more about managing your position. So these days you'd use something like DeFi Saver or InstaDApp, and they sort of help you manage your position. So let's say the market's tanking, you want to quickly, let's say, close down your vault, or you want to just withdraw all your collateral. Flash loans will allow you to do that in one transaction without necessarily having to repay your debt upfront. So it's not really about profit, it's more about saving positions or repaying back positions. All right, so just being aware of time, so I'll try and get through the rest of some of this code here. So flash loans, for those interested, as I mentioned, to use them, generally you need to create your own contract. So you'd inherit from what we call the flash loan receiver base. So that's just example code, like an interface that we have in our docs. So you inherit from that, and you have your call, your flash loan call, and you would set up all the necessary parameters. So this is all the parameters. So you'd say the receiver address is this. So the receiver address is the address that will receive the flash loan assets. Generally, when I code flash loans, I have the contract that's executing it receive the funds, the flash loan funds, but you can make it go elsewhere to another contract if you want. And then in V2, or the other parameters are arrays of values, because you can flash loan multiple assets. So you just put a bunch of assets that you want to flash loan. You say the amounts of each of those assets, the modes. So with flash loan specifically, mode 0 is what everyone knows and loves about flash loans. You have to pay it back before the transaction, otherwise it reverts. With V2, we have what we call debt incurring flash loans. So that means that you flash loan, but then you incur a debt, like a stable debt or a variable debt at the end of it. So you don't have to necessarily pay it back at the end of the transaction. And a lot of people think, okay, that's just like a normal deposit and borrow. It is sort of, but the important part here is that it's reversing. So you're borrowing first and then you deposit afterwards. So the use case for this is that if you want to do leveraging, so let's say you flash loan and make some profit, or you wind down some position, and then now you can deposit it into the system to create your collateral position, right? Instead of having to do a separate transaction of depositing and then borrowing, now you're borrowing and then you're having to put collateral position. So that's a pretty cool scenario, which allows for things like margin trading. And then of course, yeah, you call on behalf of, and you put the address of the contract, and you can pass in some parameters, which I'll go through in a second. and with Encode, which doesn't apply at the moment, but hopefully some governance stuff will kick in soon. So you just call the flash loan function on the lending pool. As I mentioned, the lending, and you pass in your parameters. The lending pool will do some sanity checks to make sure there's enough liquidity and to make sure what you're passing through is valid. And then if everything checks out, it will send the requested amounts to the receiver address, which is in this case your contract. And then it will call the execute operation function. So you have to make sure that your contract has this execute operation function, and it has to, the signature has to match this exactly, and it will pass in all the relevant parameters. But once you get into this function of your contract, you can assume that you have whatever funds you've requested. So this is when you do whatever actions you need to do. Hopefully it's profitable, and so then you can pay back the loan. In version 2, as opposed to flash loans in version 1, instead of you sending back the amount to pay back the flash loan, now the lending pool contract will pull it from your contract. So you just have to make sure that you approve the lending pool address to be able to pull those funds. And as I mentioned, if the lending pool can't pull all those funds that are owed, including the fee, then the transaction just reverts, and it's like it was never done before. So I think that's probably all the time we have, actually, because I don't want to take up too much time from Patrick, and I know he has a lot of cool things about Chainlink. So yeah, I think we can end it there. That's sort of the main bits. If you want to learn more about governance and some other features in Aave, you can probably jump on our docs or in our Discord. We're pretty active there.
Awesome. Oh, David, that was fantastic. Really, really nicely done. Would you mind staying for a few minutes? I'm sure there's a few questions left over that people will kind of wait until the end.
Yeah, sure.
To have that answered. Thank you very much, David. That was brilliant. Right, moving on, we have, first of all, if there's someone who is, I'm going to mute that person successfully. We have Patrick, who is a developer advocate at Chainlink. Chainlink are the foremost oracle in the crypto space, and I'm really pleased, and so essential for a lot of the DeFi kind of ecosystem and infrastructure. So I'm delighted to have kind of Patrick here with us today, and yeah, to tell us more about Chainlink, and yeah, kind of go deep. Patrick, great to have you, and over to you whenever you're ready.
Awesome. Thank you so much for having me. And yeah, it's always awesome to hear David actually speak about Aave too. And then people are like, oh, can you use Chainlink with Aave? And then David goes, well, Aave does use Chainlink. So that makes life a little bit easier. So yeah, David obviously, killing it once again. But yeah, let me share a screen and we will jump into it. Cool. Can we all say that okay?
Yeah, perfect.
All right, great. So we're going to talk about connecting your smart contracts to off-chain data, financial definitive truth, APIs, purely random numbers, and really all things oracles, right? Because that's the main thing that Chainlink kind of enables and helps for our smart contracts. So obviously, Chainlink is this tool that allows our smart contracts to be better, to empower them to do all these extra things. And if you don't know anything about smart contracts, I'm not going to go too much into them here, but in order to understand oracles and kind of their importance, there is a little bit of prerequisite knowledge to know about smart contracts. So smart contracts, obviously, there are these decentralized agreements, these digitally superior agreements, and they fix these issues of extreme centrality, contract conflicts of interest, enforcement, and transparency in the traditional world. I'm pretty much going to stop right there when it comes to smart contracts. I'm hoping that the crowd here is kind of in the know with smart contracts and their value add. So these smart contracts are fantastic, right? They're amazing things. They allow us to build things like Aave, like all of DeFi, like NFTs, like all these amazing different applications. But they have this big problem, right? Traditionally, these blockchains are unable to connect to external systems alone, right? Alone, they cannot do this. They can't connect to any data feeds, any APIs. They can't make any payments. They are purely these walled gardens, right? And they can't interact or get any validated, truthful data. And then the question then becomes, okay, well, why not? I thought smart contracts were supposed to be the future. Like, why they can't even make an API call? What's going on? And the reason for this is that blockchains are deterministic, right? Excuse me, they're deterministic by nature. They're intentionally deterministic. Because they're deterministic, a blockchain, a smart contract platform, like Ethereum, is able to reach a consensus very easily, right? So each node can actually talk to each other and say, hey, 1 + 1 is 2. The value of this this person's wallet is now 2. Every node can go, okay, let me check 1 + 1. Okay, yep, that equals 2. Great, we've reached consensus. The value of this person's wallet is 2. Now, if we're working with non-deterministic data, that's when it can become a little bit trickier, and that's when it doesn't actually work. That model starts to fall apart. If one node says, okay, guys, I'm going to get a random number, here's my random number, another node is going to say, well, I'm going to get a random number, here's my random number. My random number doesn't match your random number, and it's very likely that none of the nodes will get a matching random number. Or maybe they want to make an API call. And so one node says, hey, I'm going to call this API, here's what it responded with. And then another blockchain calls it, another node calls it and goes, well, I just called it and it's different. It changed. And that can happen, right? Because an API can change. It can go down, it can get hacked, it can be depreciated. All these things can happen. And so calling external data and working with the outside world breaks basically all blockchains, and that's why they are intentionally deterministic, right? So they can always reach this consensus. Now, again, this leads us to this problem, the smart contract connectivity problem, where, okay, great, well, we have these digitally superior agreements, but they can't even do the same things that our regular world does. They can't connect to market data, they can't make retail payments, they can't do bank payments or any events data. And this is obviously a huge limiting factor for smart contracts. And I will be answering the chat in just a minute. So, excuse me, at the end of the presentation here. So if you have any questions, feel free to drop it into the chat. I love making these a little bit more interactive. But yeah, in any case, so this leads us to what's known as oracles or blockchain oracles. So blockchain oracles are any device that interacts with the off-chain world to provide external data or computation to smart contracts, right? So this is the answer to here. So we need some type of lens to kind of peer into these blockchains, to look into these blockchains and say, I want to get this data from here, I want to send this data into the blockchain, or the other way around. These oracles are bidirectional. They can bring data in, send data out, and it doesn't even necessarily have to be data. It can be really any type of computation. So these allow those API calls to be made. Now, the oracle problem actually doesn't end there. So there's one additional piece. A centralized oracle is going to be a massive centralized point of failure for these protocols, for these blockchains. If we have all of our logic, right, built on the blockchain and built in a decentralized manner, we now have this wonderful decentralized logic, logic layer. There's one side of your smart contract. Obviously, you want to have a data layer. You want to have data in the smart contract as well. So we need some type of data layer. We have our smart contract layer, which is decentralized logic. If we have one node bringing the data into our smart contract, now all of a sudden we have a centralized data layer. And now basically just by fact of having a centralized data layer, our entire smart contracts is now centralized, because one person can come in, flip off the data, misreport, something bad happens, who knows, and now the entire application is compromised. We saw a good example of this with kind of the GameStop world, where, well, both the computation and the data was centralized there, but the entire market got shut off because one representative, failed at a certain aspect, and the entire market for those working on that protocol, which was Robinhood, got shut off. Whether or not it was the intent of getting shut off, maybe there really was a liquidation issue. It doesn't matter. They had a failure, and the entire application failed because they had a centralized point there. So these are bad. So getting your data through one node is really bad. Getting your data through one data source is really bad. And it's the same reason why the same paradigm where having our decentralized logic layer is so important, having our decentralized data layer is so important to move to these trust minimized, these trustless agreements. And this is where Chainlink comes in, and this is where Chainlink really shines. So Chainlink is the decentralized Oracle network. So it's a way to bring data in, and it's a way to do external computation, off external decentralized computation in a decentralized, secure, reliable manner. Now we can have our full end-to-end applications using some type of data and using some type of external computation. And this is really the promise of smart contracts and the promise of Chainlink 2. Chainlink basically takes these smart contract platforms and empowers them and supercharges them to be able to do anything, right? Any input, any output. You can now customize your smart contracts with a decentralized Oracle network to keep that trust minimization and keep the decentrality, but still have the feature richness that we see in kind of the centralized Web 2 world. And here's kind of an example of what that actually looks like with one of Chainlink's latest releases, Chainlink OCR, or off-chain reporting, where a whole bunch of nodes off-chain say, okay, we want the price of an asset. They're each individually going to make those API calls. Now they're going to kind of talk to each other, say, hey, let's get the median here, let's get the average price, and then they each sign a transaction and send it in one transaction on chain. And now you have a single kind of definitive source of truth of what the price of an asset is. And this pricing example is actually one of the most powerful and one of the most widely used solutions, especially in the DeFi realm right now. So Chainlink has gone ahead, found many of the most powerful node operators and had them spin up Chainlink nodes, partnered with some of the best data providers on the planet, and built what's called Chainlink data feeds or Chainlink price feeds. And these are decentralized price points that are aggregated to give us a definitive source of truth, right? And it's a way for us to figure out what the price of an asset is in order for us to use it in our smart contract. And there's not only is having this decentralized data and this powerful secure, reliable data really good, but it's incredibly important when working with smart contracts, especially to have data like this, to have decentralized data, because once you deploy, once you launch, that code is out there. It's not, you don't have the oversight in a smart contract to actually go in and fiddle and change a couple of knobs, right? Once you deploy, it's out there and anybody can interact with it. And we've seen way too many attacks from protocols, saying, hey, we're gonna do a centralized solution, or we're gonna do a half-baked solution, and then they lose millions of dollars. We see a lot of people talk about Oracle attacks. About flash loan attacks, and oftentimes those are just Oracle attacks, where somebody uses a flash loan to crash the price of an Oracle. And since whatever protocol is using that Oracle, using that centralized Oracle, is using that centralized Oracle, and the price tanks or the price spikes, now that whole protocol is compromised. So it's incredibly important, especially in the DeFi realm, to use decentralized, reliable, secure data here. So, for those of you who are unfamiliar with DeFi, I think hopefully most of us are. DeFi is decentralized finance. It's kind of this new paradigm for creating self-sovereign money and being able to kind of do whatever we want in a decentralized manner, interact with protocols in a decentralized manner. And here are some of the main some of the big projects that are using Chainlink and DeFi, or just a few of them. There's I think Chainlink right now is helping secure something like $15 billion in the DeFi realm, by protocols such as Synthetics, securing, 2.2 billion, Nexus Mutual, Set Protocol, Aave, of course, we just heard from David, using Chainlink to bring pricing data into their assets so they can, into their protocol so they can do whatever they like with it. So now I actually usually will pop into Aave and be like, here's what they're doing, here's how you can kind of get here's what they're doing to get the prices from Chainlink, and here's kind of their borrowing and lending protocol. But David just went, and hopefully you guys know a lot more about Aave now. So, but yeah, definitely go check out Aave. They are a fantastic protocol. So And here's the code for actually working with and getting the pricing data from Chainlink. So we can see it's really actually just making one call, this dot latest round data call on the price feed aggregator contract address. And I will go into a live demo of this in a little bit, but this is basically what the code looks like. And we can find everything at docs.chain.link. So getting this pre-boxed, this out-of-the-box decentralized data is fantastic, right? We're able to have a decentralized Oracle network, get data through that decentralized Oracle network, but we want to do other stuff too, right? We want to get random numbers, we want to make API calls. So how do we do that? So Chainlink is more than just getting data, right? It allows for all this external computation to happen. Random numbers is an example of one of those external computations, right? Because getting a random number traditionally, for those of you with more computer science backgrounds, you know that it's actually really difficult to get true random numbers in computer science systems. When you do like math.rand in Python or JavaScript, right? What it's actually doing is it's going to someplace in memory saying, this looks good. And it grabs that and it returns that to you. But the number really isn't random because it's going to someplace memory and grabbing that and sending it to you. So it's really only pseudo-random. Now, in a deterministic system like a blockchain, it's even harder to get a truly random number. Right now, kind of a workaround a lot of people do is they'll hash the block hash. But the issue there is you're actually giving the miners the opportunity to influence or even enforce, certain numbers to be picked. So if that's how you're going to use your randomness, you're actually basically ruining any fairness or any true value that can be generated from your smart contract. So we want to use something where we have a way to provably verify that we're getting an actual random number. And that's what Chainlink VRF does. Chainlink Verifiable Randomness function. And it allows for us to get randomness into our smart contract in a truly verifiably random way, which is kind of this mind-blowing thing that we can have a provably random number, but basically we just peer off chain to a Chainlink node. Chainlink node generates it using a seed, a user-provided seed phrase, and it works with an on-chain contract that actually verifies the randomness. So it's a really, really powerful application. And a lot of different protocols like Aave, like Ether cards, like a lot of different protocols are actually using these random numbers to do just whatever they want to do. So Aave and Ether cards are actually particularly fun because they're both NFT platforms, and they're using the random number to generate these provably random, provably scarce NFTs, right? Because they give their NFTs different stats or different packs based off what the random number returns, and that's not something that you could do in a centralized system. Another big one that I should have put on here is actually Pool Together, and they're kind of like a decentralized lottery where everyone kind of stakes together, and at the end of every week they assign a winner based off of the Chainlink VRF returning the random number. So and those are two kind of the big out of the box. You can go ahead and use these right now features, but again, Chainlink can be customized to do whatever you want, any input, any output. And here's just a snapshot of the documentation, which we'll go to in a minute, of being able to make these API calls and make any API call. And if there's not an API call that exists, we have a little bit of documentation to build what's called an external adapter, which will allow you to basically create your own API to be digestible and executable by a Chainlink node. And that brings me to this page too. For a lot of you who are looking for ideas, looking for solutions here, we've written an article called 77 Smart Contract Use Cases Enabled by Chainlink. It is a fantastic article if you're looking for a little bit of inspiration. We won't go through all of those right now because there are a lot, but we can just go through a couple really quick ones. Again, Chainlink VRF to create, randomized NFTs, really, really powerful. Anything in DeFi, really anything in DeFi. Anytime you need data, you come to Chainlink, look at kind of like the pre-boxed decentralized price feeds. And if the data is there, great. And if the data is not there, you can just pop in an API or spin up a price feed yourself, or request the team to spin up a price feed, or whatever you want to do. DeFi is absolutely, absolutely powerful, for the entire world. And we're still seeing more and more protocols be built in the DeFi space, because there's a need for so many of these protocols, and people are starting to realize that they need to flock to these decentralized, these math-based agreements instead of having to trust these centralized intermediaries. Insurance is a huge one. Getting data, for both DeFi actually, and for insurance, and for a lot of these protocols, especially even in the Web 2 world, data really is the cornerstone of a lot of these applications, right? And if the cornerstone of your application is poor, corrupt, centralized data, you're going to have an issue. So having this reliable, decentralized data it really just gives you the leg up in building out your applications here. But yeah, insurance is another example. You getting good data on, let's say, like the weather, right? Or actually the image here we're showing parametric marine shipping. If the water level hits a certain point, you pay out some insurance to like a shipping boat, which is just incredibly powerful. So, and where can I learn? Or where can you learn a little bit more about working with Chainlink? So docs.chain.link, absolutely the best place to go. And you can kind of bounce around. There's a ton of different links to learn, whatever you want to do. If you're a total beginner, highly recommend checking out the beginners, the basics tutorials. So it's both written and there's video. You can follow along step by step. And not if you know nothing about smart contracts, if you know nothing about Solidity, you can even follow along, because they're meant for absolute beginners. So it'll go through helping get you set up with MetaMask, helping you, make a VRF call, make an API call, working with the data feeds, etc. And it always has the most up-to-date faucets if you're working with specific testnets as well. You can go to the Chainlink YouTube. So we've done a ton of workshops. We just wrapped up our last hackathon, actually, where we did basically we created like a 0 to hero playlist, basically getting started, not only with just Chainlink, but just smart contracts in general. Because again, the Chainlink really is just, it's this fantastic tool that takes smart contracts and brings them out from just being able to do token transfers and kind of keeping everything this walled garden to saying, hey, these contracts can actually affect everybody's everyday lives. So there's these things that supercharge these smart contracts. So we show 0 to hero for smart contract development and Chainlink development. And there's 2 playlists. We have Chainlink engineering tutorials and also developer workshops here. Blog.chain.link, the developers tab, there's just a ton of random guides to do just wonderfully random stuff. Build randomized NFT, work on specific chains, build proof of reserve, whatever you want to do. A whole bunch of different examples. And then we also have our starter kits. These are pretty much anytime I start a new project, because I make a ton of projects in my spare time because it's an absolute blast. I always start from one of these because it's just this wonderful boilerplate code. It has kind of a lot of bells and whistles, a lot of example contracts for you to build from. And it makes life 1,000 times easier. So definitely reach out, join the community, have fun, jump into the Discord. Incredibly active community in Discord. For those of you who are looking to get a little bit more technical support, we highly recommend checking out Stack Overflow or Stack Exchange Ethereum questions, or asking questions there. There's a ton of community members who will answer pretty quickly on there. And then you can also refer back to it later when you forget. That's actually pretty much why I use Stack Overflow so often, is because I'll find something out and be like, oh, this is great. And then a year later, I'll be like, wait, I don't remember what the answer here was. And then I'll pop on Stack Overflow. And again, those starter kits are fantastic, and the Chainlink documentation. So with that, I will take a couple of questions and then we'll go into a few demos. So I see a few questions have built up here. Let's take a look, see. Okay. How do you verify the inputs from Chainlink nodes are actually correct? This is a really good question. So let's look at, actually, let's just go data.chain.link. So there's I'm gonna answer this the way I think that you're asking it. So for like the data feeds, right? Here's an example of the data feeds. Here's like a visualization of what's going on. So we have all these nodes on the right that are responding with data, and it's getting aggregated to this answer on the left. And each node is responding with kind of their own answer, right? You can see all these different nodes, they have different answers. They have different, well, they all have the same dates, but you can see like on Etherscan, their answers and stuff. But in the same sense that Ethereum doesn't validate or doesn't know when a node is going to be malicious. The way that the way that Ethereum validates if a node that's being malicious is it takes the Ethereum value and kind of matches it up against every other node, right? It's this decentralized network. Chainlink does the same thing. It takes these values and tries to match them up with every other node's answer, but the consensus protocol is obviously different, right? It's reaching this consensus by taking a median. And the thing with these is that every single one of these nodes, every time they respond, they make a transaction on chain. Guess what? That transaction is going to live on the blockchain forever. So if you're a node that's constantly, giving bad data, it doesn't really matter because there's so many other nodes that, your answer is basically going to be ignored. But there's a record of that. And there's a very high likelihood that the node operators and the projects using them are going to say, hey, you're responding with really bad data and we're going to kick you off the network, right? So it's kind of the same sense that the same security model that Ethereum has or other smart contract platforms have. There's basically a way to say, hey, you're not behaving, we're going to punish you in some sense. Good question. Will Chainlink do even reverse Oracle, blockchain's data to the world? Yes. I've done a ton of different examples of really silly ones too. Like I did an example where I had a smart contract order me a pizza. So it's making an API call to the real world, obviously sending some data to the real world to make a pizza, which was really silly, but really fun and really shows kind of the total end-to-end customizations. We've seen projects where people, send tweets from smart contracts, get Twitter verification, send some type of bank payment. It's like I said, oracles are bidirectional. So reverse oracles definitely I think can go end to end. When will Chainlink be on Avalanche? So Avalanche is actually an EVM compatible blockchain. So I've actually demoed this and it works really, really well. You can spin up a Chainlink node on Avalanche the exact same way you spin it up on Ethereum. And since again, Chainlink is a decentralized open source network, anybody can do this. Anybody can spin up a node. Anybody can work with any chain. So right now, if you want to, you can go ahead and spin Chainlink nodes on Avalanche. I think having kind of more, or I think the question is more like, when will the larger community be there, and some of these independent node operators be offering these price feed services? I would assume pretty soon, because Avalanche is definitely picking up a lot of steam. Aave docs mentioned some of the awesome info David mentioned. Yeah, Aave docs are fantastic. If Chainlink went down, wouldn't the whole DeFi go down? So this is a really good question. So that's kind of like asking, if Ethereum went down, wouldn't all of DeFi go down? I mean, if Ethereum went down, I mean, yeah, pretty much all of DeFi would go down. But it's really hard to imagine every single Ethereum node going down, right? And Chainlink is the same way. It's really hard to imagine every single different independent Chainlink node going down, because it's not just one entity. Like Chainlink isn't just one entity, it's a group of entities. It's a decentralized network. Ethereum isn't just one node, it's a whole bunch of nodes. So the same model, the same answer goes with both. How much does Chainlink cost per transaction? How long does it take to build your own API? These are good questions. I'm going to answer a little bit quicker just so I can have some time to get to the demo. The answer is it depends. If you're making an API call, you do pay a little bit of link. This is like the Oracle gas, basically. And it depends. Each node can actually set their own prices. So it really depends. Like right now, if you try to get like an API call on Polygon, I think most nodes are offering around like 0.0001 link or something like that. So like a few cents. On Ethereum mainnet, it's a little bit more because they need to cover gas costs, but you can check everything in the documentation because there will be like a fee thing there as well. And if you're not muted at the moment, could you just please mute yourself? I'd appreciate that. Thank you. When Chainlink in an Encode hack? Well, hopefully soon. I'm assuming an Encode hack, we're talking about like the Encode Club hack, right? That's what we're talking about. I'm hoping after this presentation soon, right? How do you know that the 31 nodes are getting their data from, how do you know that the 31 nodes are not, well, I'm assuming you meant not getting, oh, okay. are not getting their data from the same source? Yeah, this is a really good question. This one's a little bit harder. So right now, all the node networks are pretty have like a really open communication community, and everyone's talking and about like, okay, who should be, you know, delivering what data from where, keep it really Sybil resistant and keep it really decentralized. It's a little harder to say this is the exact one that they're using and prove that they're getting, you know, the data from a certain place. However, again, everything that they report on chain is live, right? Everything that they report is live, permanently recorded, and there's whole teams that are kind of dedicated to the reputation and checking to, you know, make sure nodes are being honest and everything. So that's a really good question. That's a really good question. All right, cool. Well, I have like 2 minutes left here. So in my quick 2 minutes, we're going to do the fastest. We're going to do the fastest demo ever. So here in the documentation, I basically live in the documentation. We're just going to do it quickly, showing the getting the latest price. If you want to do a randomness API, there's some examples here and here. And again, the randomness and API, they follow this request and receive. So you do have to do one additional step that we're not going to show here. But again, if you follow the tutorials, you know, the beginners of basics, intermediates, random numbers, it'll show you, you know, everything, how to work with these if you're completely, totally lost. But let's go to get the latest price. We'll hit this deploy this contract with Remix button. It'll bring us over to Remix, and we'll get a gist for the price feed contract. And I have a ton of gists on the left here. But if you haven't worked with Remix before, it'll just pop up one right here. Remix is a web IDE. It is a integrated development environment. It's a way to kind of quickly test and deploy smart contracts. And here's our code for working with the Chainlink aggregator. Again, I'm going a little bit quick just because we're a little bit shorter on time. Basically, what it's doing is once we deploy it, we point this aggregator v3 interface to this address, which is the address of the of FUSD, the FUSD aggregation on the Coven network. And in the documentation, you can find, you know, all the different addresses for different chains in this contract addresses section. You know, like all these different addresses. You know, maybe you want, you know, 1 inch ETH, 1 inch USD. You know, whatever you want. You just grab the address and you pop it in here. Again, it is network dependent, so you'll see like Coven has different ones, and Rinkeby has different ones, and Mainnet has different ones, and Polygon has different ones. But you grab the address, you pop it in here, and then basically you just call this get latest price function on it, and we'll go ahead and compile this, and we're going to deploy. We're going to deploy to injected Web3, which means we're going to be deploying to whatever network that my MetaMask says, which is going to be Coven right now. We're going to go ahead and hit deploy, confirm. We're going to be deploying to Coven here, and again, so these are only going to work on kind of a blockchain where these aggregations occur. For those like who are looking to do this locally, normally what I'll do is I'll just like deploy a mock aggregator contract, and we have some videos that show you how to do that as well. But you know, once it's deployed, we can interact with the contract here. We hit get latest price. And now we have the latest price of Ethereum in USD in our contract. And then the question then becomes, why is it such a big number? Is Ethereum really that expensive? This is great. And the answer is no, actually, Solidity doesn't work with decimals so well. So it's multiplied by 10 raised to the 8th. So this is the actual number here. Are there any other questions? I know we're actually pretty much out of time right now.
Oh, if we go a few minutes over, it's absolutely fine.
Okay. Yeah.
Any other questions, everyone?
Yeah.
Or question here, what's next features for Chainlink? What are the next features for Chainlink? Let's go more.
Yeah, great question. So a lot of stuff. I think some of the most exciting things from my perspective are going to be a lot more of these external computation, these decentralized external computation, right? So smart contracts are wonderful, but they're incredibly expensive to do a lot of computation, right? If I wanted to build like a machine learning algorithm to get all the data for something and do some crazy quant model, doing all that on chain would get incredibly expensive. And so actually, if you want to read the Chainlink white paper V2, which just came out maybe like a week or two ago. I highly recommend. It's a long read, but there's just so much stuff in it that's really exciting to read and learn about. Is we actually will probably move more towards a model of what's called like hybrid smart contracts. So in a way, Aave, Synthetics, all these protocols that use some type of off-chain interaction are in a sense a hybrid contract. So they're really using Ethereum as kind of the settlement layer and the majority of the logic layer, but they're still getting pricing data from off-chain, which is really exciting. So having more of these off-chain things come up where maybe, maybe there's an off-chain service where it's just a machine learning algorithm for getting some technical analysis on a price, or maybe a decentralized way to get identity. That's something that I think is going to be really exciting because you need an oracle to actually verify someone's identity. So to have these verification services, that's an external computation that would be wonderful to have like a de facto way to do that through Chainlink, cross-chain interoperability, or the likes. There's just, if you read the white paper V2, there's a ton in there. One other thing I did want to point out as well, this is something that I'm really excited for personally, as well as professionally, is this thing called the Keeper Network. So it's a way for you to upkeep your smart contracts in a decentralized manner. So someone upkeep or do some action, right? So an example of this would be if you wanted to do like rebalance your portfolio every quarter or something like that, right? It would be a way to, in a decentralized way, upkeep an entire protocol's portfolio, and say, hey, if time is 6 months, then do this. So almost like an if this, do that, almost like a zapper or like a IFF of the Web2 world. So there's a ton of these, a ton of things you can build through this in a decentralized manner that I'm just really excited for. This is the Keeper Network. Good question. What other questions do we have here? And will there be any changes with new L2s? Okay, so this is a really good question too. So the other thing that I'm really excited about is Chainlink getting a lot of support and adoption on a lot of these other chains. So somebody mentioned Avalanche, Chainlink data feeds are live, and have a really good following on at least what is it right now? Ethereum, Binance Smart Chain, Polygon, XDAI, and a couple other chains. But yeah, having Chainlink live and really with a really solid following on a lot of these protocols. And will there be any changes with new L2s like Optimism, Arbitrum? Chainlink will operate on those as well, because Chainlink is a blockchain agnostic technology, can work with any layer 2, or layer 1. So not really any new changes. And Chainlink itself is layer 2. Last cue to Patrick. All you want for Christmas is what? So I kind of a funny story. So I ordered this sweater. All I want for Christmas is Chainlink. Obviously, it's April right now, so it's not very. Doesn't really make sense for me to be wearing it. But I ordered this sweater from this guy, and he ended up sending me like the wrong thing a few times. So I kept sending him back, hey, like this is wrong. Can we fix it? He ended up sending me, I think, like 9 hoodies of like this exact thing. So now I just have like a ton of Chainlink sweaters and hoodies because he sent me a whole bunch of the wrong ones. And yeah, now I just wear it a lot. So yeah, all I want for Christmas is Chainlink, but it's very out of season. Maybe I should get like all I want for spring is Chainlink. If you guys see any awesome Chainlink swag, like boutiques or Etsy's, let me know. I'm always looking to find more like Chainlink swag. Always looking to find more blockchain swag in general. So like, let me know if you guys find some other cool swag for blockchain apparel.
Awesome. Well, Patrick, thank you so much for, and David as well, for such brilliant talks. And I know all my screen's just gone down. Give me a second. I think I'm still here, but my screen decided to unplug itself. Anyway, thank you so much, David and Patrick, for such brilliant talks this evening. And I know the students really appreciate it, and a lot of them who've been going through this whole kind of process of learning about DeFi for the first time through this kind of series. This is event 8 with a few more to go, and this is probably I'd say one of the best events we've had. Am I allowed to say that? I think I'm allowed to say that. So that was absolutely fantastic. So thank you both of you for your time and for lending your experiences and insight today. We really appreciate it.
Awesome. Thanks, everyone.
Yeah, thanks so much for having us.
Awesome. So for students, attendees, and anyone watching on the YouTube, thanks for coming. The slides and the YouTube will be up tomorrow morning, I should think, European time. And the next event is on Tuesday with Nick Grossman of Union Square Ventures, followed the week after by, I believe we've got an AMA with 1 inch with Anton Bukov. And we finish off with a hiring event, which is going to be moved to the Thursday, the 13th of May. And that will conclude our slightly now, I think, 12-week, not 10-week DeFi Club series. So Patrick, again, thank you again. David, thank you very much. And see you all. Thank you all for coming, and see you all very soon. Cheers all.
Thank you.